All right. Hi, everyone. Welcome back to the second video. In the first video, we basically saw how to subnet when we were given an original prefix and a new prefix. So we just followed the new prefix and we subnetted it accordingly. In the second video, we will not be given a new prefix. Rather, we have to find the new prefix, but we will be given the original prefix and the number of hosts and number of subnets we need in our particular subnet. So this is a stepping stone to making VLSM schemes, basically. So this video will prepare you for the next one. That's what I mean to say. So yeah, let's just get started with the video. And so the first problem here, again, is the easy one. It says that we have an original prefix of /24, and our requirements are we need at least 12 hosts and at least 14 subnets in our subnetting scheme. So the number of bits we'll borrow here will be determined by the number of subnets, because as we saw in the previous video, number of subnets is basically equal to 2 to the power of number of bits that we borrowed. So we can just start off by typing in all ones for the new subnet mask, because we are not removing any bits, rather we are adding in bits. So coming to the last one, now we know that we need to borrow a number of bits to create at least 14 subnets. If we borrow 1 bit, we're creating 2 subnets, because 2 to the power 1 is 2. If you're borrowing 2, we're creating 4. If you're borrowing 3, we're creating 8. So this still does not satisfy the number of requirements, which is 14. But if we borrow 4, then we get 16, which satisfies this number. So we'll stop at borrowing 4 bits, and then we'll leave the rest as the host bits. So the number of bits we've borrowed is 4. The new mask in decimal will be, again, we just take this number and we convert it to decimal. So 4 ones and 4 zeros. This number is 240, because 128 plus 64 plus 32 plus 16. So our mask basically becomes 255.255.255.240, because the first 3 octets are all ones, which means 255. And then the last octet is 240, which we just calculated. So the new prefix now becomes, since we're taking in 4 more bits and adding those 4 bits to the original prefix, so our new prefix basically becomes /18. /28, my bad. Yeah, so the number of hosts, as we calculated again in the previous video, I'll be running through these fairly quickly because we have 3 examples for this video. If you still do not know how to calculate the number of hosts and subnets, I explained that in greater detail in my first video. So the number of hosts will be 2 to the power of number of bits left minus 2. So we have 4 bits left as zeros. So 2 to the power of 4 is 16 minus 2, because 1 for the network address, 1 IP for the network address, and 1 IP for the broadcast IP, or the broadcast address. So that's how we subtract 2. Number of subnets will be 2 to the power of subnets that we've taken, or 2 to the power of number of bits that we've taken. So 16, because we've taken 4 bits. We're not subtracting anything here. Number of subnet bits will be, again, 28 minus 24, so 4. Number of host bits will be 4, because we're left with 4 host bits right here, 4 zeros. Okay, now in the previous video, we basically had calculations within our subnet. So the first IP of our subnet, the last IP of our subnet, last usable IP and the first usable IP, followed by the broadcast and the network address. But in this one, we'll be calculating the network addresses of different subnets within the original IP or the address we've been given. So the IPs of all our subnets, basically. So let's just type in first, second, third, and then the last one. So we'll find the ranges of all of these. The first one always starts with 0, so 192.168.1.0. And so again, we'll be using the magic number technique here. Hey guys, so in the coming clip, I've corrected a mistake that I make later on in the video. So please watch that before continuing in the video. Thanks. All right, so hey guys, this is the future me. I just realized while editing this video that I actually explained the number of magic, the concept of the magic number in a wrong manner. So what I mentioned here was, since you're borrowing in 4 bits, our magic number would be 2 to the power 4, which becomes 16. This is incorrect. I realized this later on when I was actually recording, doing this part of the video. So the concept of magic number in simple terms is that if you're borrowing in 4 bits in here, if you're borrowing in 4 bits on any octet, let's just clear this off. So if you're borrowing 4 bits, we type in 4 ones here in the binary to decimal table or whatever you want to call it. And the magic number basically becomes the last digit of 1 here. So if our 1 here is ending on 16, then our magic number becomes 16. If our 1 would end here on 8, our magic number would have been 8. But if our 1 would have ended here on 128, then our magic number becomes 128. So it depends on which number or how many bits you're taking, and you put those bits in the magic number of table when you're converting, and wherever the ones stop, basically the last one becomes your magic number. So this is how you do the magic number. Please, my apologies for the one for the concept I explained in here that is incorrect. So yeah, hope this helps, and yeah, back to the video. Since the number of subnet bits is 4, we've taken 4 bits, so the magic number here will be 2 to the power 4, which is 16. So our subnet goes by increases by 16 every time. So the range for the first one will be 192.168.1.15 because from 0 to 15 is basically 16 numbers. And then the second one starts from 16, so 192.168.1.16 all the way till 31. So 192.168.1.31. The third will start from 32 and all the way till 47. And then the fourth one would start from 47 and so on. And then we come to the last one, which starts from 192.168.1.240. And if we add 15 or 16 to 240, it's basically counting the number 240, it's basically 255. So 192.168.1.255. So our broadcast is 255. So the network address of the first subnet, as we calculated, will be .1.0. The second will be .16. The last would be 240. Now they could ask you the broadcast address of each subnet as well. We've calculated that as well. Or they could ask you what's the first usable host for the first subnet. So if that's the case, then the first usable host will just basically be +1 in the network address, so 192.168.1.1. And then the second would be .1.2 and so on till we reach the broadcast address. And similarly for these, it'll be 192.168.1.17. This will be 192.168.1.33. And this will be 241. So 192.168.1.241. Yeah, so these will be the usable hosts, and you can calculate further on if needed. So these are the answers for the first one, the easy problem. Now moving on to the second problem, they've given us a prefix of /16, which means that our subnet mask in binary will be the first 2 octets will be of 1s and the last 2 will be of 0s, and in decimal it'll be 255.255.00. So the new subnet mask here, again, we are not removing anything, so these will all be 1s. Now coming to this one, it's asking that we need at least 500 subnets. So we know that if you're taking in 1 bit, we're creating 2 subnets, 2 bits, 4, 8, 16, 32, 64, 128, 256. So we've used all 8 bits in this octet, but it's still not satisfied the 500-bit number. So we'll move on to the next octet. So currently we've borrowed 8 bits, which is 256. If you borrow the 9th bit, that's 5 and 2. So now it satisfies our requirement of 500 subnets. And then again, we follow them by zeros because we don't need to borrow any more bits. So our number of bits borrowed here will be 9, 8 plus 1. The new mask in decimal will now be 255, 255, 255, because this one's all 1 as well. And then this one's the first one is 1, so just 128. Now the second, the new prefix here will be slash 16 plus 9 because we've borrowed in 9 bits. So slash 25, sorry, slash 25. Yeah, now the total number of hosts we have will be, we left with 7 bits. So 2 to the power 7 minus 2, which is, we have our bit table or the 2 to the power table here. So 128, and 128 minus 2 will be 126. So that satisfies our 100 host requirement as well. So the number of hosts is 126. Total number of subnets as we calculated previously, 2 to the power 9, so 512. Number of subnet bits will be 9. Number of host bits will be 7. And yeah, now coming back to the first, second, and third subnets. So this one, again, I had a brief explanation about this in my first subnet and the second problem, which is a more harder problem. But yeah, basically what we have to do here is the first subnet, again, will start off with 0. So our first subnet will be 10.2.0.0. And here the magic number, since we've completely used up this octet in ones, and we've entered the 4th octet, and the magic number of the 4th octet is 128 because we've borrowed the first bit. So yeah, so now using the magic number technique, what we can do is, we know that they'll go up by iterations of 128 first, and then we move on to this octet. So the first one will be 10.2.0.127. And this one will be starting with 128. So 10.2.0.128 all the way to 10.2.0. Sorry, 10.2.0.255.255. And then, sorry, this one here will be 0. My apologies. Yeah, now we move on to the third octet because we satisfied this octet already. So 10.2.1.127. Sorry, 128. And my bad, this will be 0. Sorry. And this one will be 10.2.1.127. And then 10.2.1.128 and 10.2.1.255. Yeah, so this is how our range goes. So we're iterating first with 128, and then once we've reached 255, we move on to the third octet and start off with 0 again in the 4th, and then keep going. So our first network address will be always starting with zeros. Our second network address will be 128. And the last one in our example here will be 255.2.128 because we've reached 255 in this in the third octet, and now we are starting with the last one. So this range will basically be 10.2.255.128, and this goes, 128, and this will go to 10.255.255. So this will be the broadcast address for the last subnet in our example. So yeah, using the magic number technique, again, we found out that the magic number was 128 here, because if you're using this binary to decimal converter and you only have 1 bit here, that means we're only using 128 as a magic number. Similarly, if we were to have 4 ones like we had for the first video, then our magic number would have been 16 rather than 128. So yeah, that's how you do this one. And now coming to the third and the final problem, which is probably the hardest because we have reached over 30,000 in number of hosts. So in this one, we've been given an original prefix of /8. Number of subnets remains the same. We need 500, and number of hosts this time has rather increased because our prefix has decreased. So let's start off. The first one will always be all ones. Again, to have 500 subnets as we calculated in the previous example, we need a total of 9 bits. So all ones for this one, and then we borrow 1 from the next octet, followed by all zeros, and then the last one will be all zeros for this one. So these are all the host bits, and these are the ones that we added are the new bits borrowed of the subnet bits. So the number of bits borrowed here will be 9 again. The new mask would be 255.255.128.0. The new prefix would be 9 plus 8, so /17. Now, total number of hosts. So since we have 8 plus 7, 15 bits. So using our table, we can check that 15 bits is 32,768 minus 2, 1 for the network, 1 for the broadcast. So that gives us 32,766, if I am right. Yeah, 766. Total number of subnets will be 5 and 2 because you're borrowing in 9 bits. 2 to the power 9 is 5 and 2. Subnet bits will be 9. Host bits will this time be 15. Okay, now coming to the network addresses. So again, the first one we're starting off with will always be 0. So the first, second, third, and then let's go to the last one. The first one will be 10.0.0.0. So our magic number again is 128 because the first bit here, the only bit that we've borrowed in the third octet is 1. So the first one, so that means 128 if you're using this table again to find the magic number. So yeah, using that magic number, we can say that our first subnet goes from 10.0.0.0 to 10.0.127.255 because that's a host. And then the second address would be the 128.0.128.0 again, and then we move on to 10.0.255.255. The third one would be 10. Now we're entering 1 because we have finished this octet. Now we're moving on to this octet, and then we reset this octet, the third octet. So 10.1.0.0 for the network address, and 10.1.127.255. And then the fourth one would be 10.1.128.0, and the broadcast would be 10.1.128.255.255. And then we come all the way to the last one, which is 10.255.128.0. And the broadcast for this one would be 10.255.255.255. So yeah, we have all of the network addresses calculated. Let's just put them in the table. So the first, second, and the last one. Yep, so this is how you calculate subnetting with the number of hosts and subnets given. Hope this video helps. If you have any questions, drop them down in the comment section below. Thank you all for watching.